Warren, you continue to surprise us.
Yeah.
With what? With what? With what?
It's his choice of language color, I think.
Yeah.
That must be it.
Wait a minute, I can't quite read the shirt. I might be colorblind, but I know you look good in green. You're matching strawberry hat, which is also green. Good. For me?
Just checking to see the comments.
Yeah.
Yes.
Yeah, it seems to be working. Thanks.
Right. Thanks for touching. This one's came out of usually jet lag. This one's just, it's Wednesday and it's still always me. I totally slept through the weekend channels. Wasn't coming down with something, so I have somewhat of a defense, and I thought the sleep would help. But I did work for it. Yeah, probably. Yeah. You have to do it? I usually do too, and I totally took it out when I came. The Canadians actually rated my on the side of my junior pharmacy, and they went through and rated and took my I had to pick, so they took my fish oil and Dayquil Nyquil and one other thing, and they said because of two food groups. I'm like, I've traveled with these things for like years. And she's like, if it spread, she had a really good quote for it, but it was like, if it pours or spreads or whatever, it's worth it. I'm like, okay. So coming here, I thought, no, in the blister packs, yeah. And the fish oil. And she's like, how do I know it's fish oil? I'm like, well, you're welcome to bite into one. I wouldn't recommend it.
Yeah.
Oh yeah, you go in and they give you the individual little packages. It's not right. The last time I've been sick on an IETF was freaking Singapore 2 years ago. But I had pneumonia after this trip. Actually, I was like, bless you, 6 months I think they just put me on my so emergency airborne.
Yeah.
Hopefully.
Wow. Yes. I can't afford for that to happen because I'll be traveling until December 16th. Spending Thanksgiving in Geneva.
Oh, that's right.
Something important. ITUT study group 12, performance and quality experience, quality service. He's laughing at me. Well, it is, but what are you going to do? Anyway, I think it's time. We should get going. All right. I'm going to move this closer to me.
I'm going to let you do most of the talking mostly because I sound like very white.
Yeah.
I'm not entirely sure I want to explain that to the group.
Got it.
Is that okay now?
Got it good. This is horrible. It's too high and it's too. This should change as well, but it doesn't. So, okay. If anybody's really tall when you get up here, feel free to make adjustments. Hi, everybody. Welcome to Benchmarking Methodology Working Group. My name is Al Morton, one of the co-chairs. My fellow co-chair here, who is not a fellow, is Sarah Banks. Say hi, Sarah. This may be, she has said hello. So our session is starting now, a couple of minutes late. We have the 2-hour session here, and please move close to the front. I even moved the mic close to the front to encourage that. And if you are not subscribed to the Bmwg list and you would like to, that's the place where you can do it on this first set of slides, the agenda slides. So it's Wednesday. We have the Note Well slide, which you should have seen a few times. We work according to certain IETF processes and policies. One of the most important, which is the video recording, and also because that's going on right now, and then the disclosure of IPR, which we ask you to do as quickly as possible. And then, but the most important thing is the thing I've added at the top. We work as individuals in the IETF, and we try to be nice to each other. And that happens 99.9% of the time in Bmwg, so let's not break that record. So here's our agenda, and our first step always is to bash the agenda, to make changes. And it turns out we're going to do that a little bit today, but first off, we have Luis, who's agreed to be our note taker. Please raise your hand there, Luis, so everybody knows who you are. Thank you. And if you come to the mic to speak or make a comment, make sure Luis can see your badge so that he can get the spelling of your name. And we're taking minutes today in the Etherpad, which is allocated to our working group. So, pardon? Oh, so, yes. So say your name like the little tag says, and Luis will also be able to spell it as correctly as possible. So we've got the note taker. Everybody can help on Etherpad. We've had trouble with Jabber in the past. Is anybody connected to Jabber for this group? Yeah, and I doubt that there'll be anybody there, Warren. But yeah, but I appreciate that. You've helped us out with this in the past, and it's a big help because we're supposed to provide it. I've just mentioned the IPR, and the blue sheets are going around. This is where you sign your name. Only one blue sheet because we're a fairly small group. Be sure you get your name on it and your company affiliation and so forth. So that covers the administrative stuff, except for the agenda approval. So we're first going to do the working group status. We'll look at our charter and milestones briefly. We have some sins to apologize for there. And then we'll look to Tim Winters, who I think is here. Yes, hi, Tim, for presentation on the next generation firewall network security device performance. I'm authoring a draft on back-to-back frame benchmarks. It's updates for that in RFC 2544, so that gets us through the working group drafts. And then we'll have plenty of time, I think, for the continuing proposals, which include the methodology for VNF benchmarking automation. Raphael, are you here? Raphael is at lunch. Okay, hopefully he joins us in time. We may need to shuffle that a little bit. We have Wangbong Lee, who is going to give us a presentation on the considerations for benchmarking in the containerized infrastructure. Right on topic, and then a Yang data model for network interconnect tester management. Vladimir Vasilev is here. He's had his draft available for quite a while, and this is the first time Vladimir has asked to present it, following a successful hackathon over the weekend. And I think he also had the hack demo happy hour last 2 nights ago, right? So I hope that was successful too. I note that I apologize. I didn't make it there as I planned. But then the last sort of one we originally sort of wanted to do here was the benchmarking methodology for EVPN multi-homing devices and restoration, which we've updated, Jim Utaro and I. And then new there's new comments on service density benchmarking, but we don't have anybody here who can really take them. So what we decided to do with this time is to give Luis a chance to talk about his 5G network benchmarking again. And so that's an agenda change. I'm just describing it verbally. And then let's see, I think if there's time, I'll talk about benchmarking and the Common NFVI Telco Task Force, which is something newly created in 2019. And it actually has a lot of overlap with the work that we're doing here, containerized infrastructure, the modeling work, and so forth. But I'm going to, I apologize, I'm going to have to play search roulette to put that presentation together if there's time, which means I'm going to type CNTT and OPNFV in the in a search window, and we'll see what comes up, and I'll select from there. So, but it's just an informational presentation. I want this group to be aware of a lot of work going on there. Any bashes to the agenda? Seeing none, seeing no one at the microphone, we will move straight ahead. Raphael is remote up here apparently, so we hit the red button.
Yeah, actually, it's not Raphael, it's me, Manuel Poister, who will do the presentation for the VNF benchmarking automation because Raphael cannot make it. Okay.
Oh, Manuel. All right. Very good. Thank you for letting us know. Why don't you give us a test 1, 2, 3, 4, 5 to 10 with your audio, and we will adjust the volume because it was blisteringly loud here.
Oh, did I kick him out?
Yeah, you ate him, I guess. You won the game, by the way.
Okay, I think now it's working. Can you hear me?
Yes.
Hello, 1, 2, 3. 1,
yeah,
2,
that's
3.
a much better volume. Thank you, Manuel.
Okay, great.
All right, so thank you for that agenda bash and for being ready to go here. Much appreciated. And thank you for utilizing your audio expertise. I should also introduce our area director advisor, who is Warren Ace Kamari here at the front, dressed today like a strawberry, but that's cool. So very cool, actually. So good. So let's go ahead with those changes. So the quick status is, along the way we adopted this back-to-back frame benchmarking, and that meant we actually got some comments from folks, which I almost forgot to incorporate. So and they've been coming in very nicely. So what I had to do was wait till the submission window opened again. And so now there is a new version of that draft available. I apologize for missing the regular deadline. So I don't expect a lot of comments on that today, but we'll talk about the ones we got and how we resolved them. So the new proposals keep coming. And if you don't see your name here, it means I missed it somehow. But there's just the point is that there's a lot. And here's where we get to apologize and work with our area director to fix all our milestones, which we keep forgetting to do. So, yeah. So let's do that. But these are all the things that, in fact, some of them, for example, methodology on EVPN benchmarking. I think we've pushed the button on publication requested, right? And so for that one, we have a write-up to do, the document Shepherd's write-up. All done? Oh, cool, okay. So great. So then it's in, I guess it's in Warren's hands. That's fine. That's a busy week, I know. So let's all be nice to each other, as I said at the start. No problem, Warren. So we're woefully behind in fixing this, but we will do it. Okay, new RFCs, none. Charter update, none. We still got a supplementary page, thanks to Sarah. And you can go to this page and read it if you're new to Bmwg. And let me ask the question. Please raise your hand if you're new to Bmwg. One, two people. That's great. So you'll find this group incredibly easy to join. And the reason for that is we're all very kind to each other. But also, if you know anything about testing, you can read our fundamental RFCs, which you'll quickly find out from the list what they are, and get on board with what we try to accomplish here. It's laboratory testing, data planes primarily, sometimes control planes, and so forth. Folks who just joined us, the blue sheets have made it to the front, and if you would please sign the blue sheet so that we don't get a broom closet size room for next time, that would be much appreciated. And let's leave that in the back. Yes, sir.
Can you go back to the milestones, please?
Of course.
So I just want to give you a verbal update. If you go to Data Tracker and look at the Bmwg milestones, I think what we have here is an outdated snapshot.
Oh, really?
I did sit down and do this last year, and I looked, and it shows, with the exception of one, all of our milestones are this month, so we are technically on track.
For some of them.
Only one. Well, okay, yes, that's true. But I'm just saying, technically speaking, the clock has not run out. August 2019 was methodology for next-gen firewall benchmarking.
Okay.
Other than that, everything is December 2019.
Cool. Okay.
I know everybody's worried about our milestones.
Well, yeah. Well, but we try to keep some expectations realistic. And that August 2018 one was always aspirational. So.
Yes.
Okay, I think that's. Oh yeah, and this came up. I just sent comments to the considerations for a containerized infrastructure author team. We do have this standard paragraph that helps us get through security considerations review. And feel free to modify it, but always try to put something like this in, because the key part is that activities described in this memo are limited to technology characterization using controlled stimuli in the laboratory environment. We had a bunch of people in security go, "What the hell are you doing?" And then they finally get to the end paragraph and they go, "Oh," and they've done a bunch of typing, and it's it's better if they look at this first, I guess. I don't know. So anyway, it's a good starting place. I don't think this is the final place. Feel free to edit this as you go. And I guess that's it. Yeah.
So I just want to make a quick note, especially for newcomers with new drafts. Bmwg generally only issues, I believe, informational track drafts or RFCs. We are not on the standards track. And I bring this up because the last document that we just sent in for publication went in as standards track, and Cindy actually caught it and came back and said, "Did you intend this, or did you mean for it to be informational?" And even I missed that. So it's easy to do because so much of the IETF tends to be on the standards track, and so we tend to overlook that. So I just wanted to call out, hey, while you're cutting and pasting that paragraph that Al just had on the screen into your draft, we want to make sure that the status is informational. And if you feel there's some particular need for that exception, I guess you could let us know, but we would generally expect it to be informational.
And by the way, the history and the reason for that is that there was, at the time that was sort of decided, this group goes back to 1989, by the way. There was no process to move testing internet drafts or RFCs along the standards track. You had to look for interoperability and prove that interoperability and deployment in order to advance along the standards track. So in the IPPM working group, IP Performance Metrics working group, we figured out a way to get our drafts and RFCs on the standards track by proving interoperability in the form of measurement equivalence. And we have a process for doing that. And that process would very much apply to benchmarking methodology drafts. We could modify it a little bit, certainly apply it, but nobody has really strongly petitioned to get their draft on the standards track and use some kind of form of measurement equivalence to prove that it should be moved up to a standard. So, and we've done that successfully with a couple of the key IPPM specifications. Let me tell you, that was a lot of work, but it was worthwhile in the end. So this is something we could talk about some more. The last time I raised this, when the IPPM process was new, people weren't so interested in it. In fact, our industry has been just completely satisfied with taking these informational drafts, although they have all these requirements terms in them, and building their equipment to satisfy those requirements. So if there's no need from the community, then we won't pursue it. You guys tell us what you want to do. All right. Thank you for that. Good point. All right. So let's go back to the agenda here for a quick look. So Tim is going to be up next with the benchmarking methodology for network security devices. Welcome, Tim. This goes to you.
Awesome. Thank you. Okay, so I'm presenting on a working group draft, next generation firewall performance testing. We have a couple of updates. We posted a new draft yesterday. Yeah, I think yesterday a new one got pushed. And I'm going to talk about some of the changes and just kind of highlight them. Just a quick reminder, this is the reminder slide we have going on here. This is really creating performance testing for next generation firewalls. The last IETF draft for benchmarking firewalls was 15 years ago. It's probably time we updated. Most of the work hasn't been happening directly on the benchmark working group mailer. It's been happening through a group of companies that have gotten together at NetSec Open Forum. And it's basically 2 labs, 3 tool vendors, and 8 firewall members that have been working on developing all of the sections that are inside of this. So I'm going to report on the updates we have. First thing is we've actually started beta testing. So we have several firewalls that are in labs, both at the UNH IOL and ENTC, that are actually running testing. One of the things we're doing, and it's going to come up, is we're comparing measurements from multiple tools. So we have multiple tools at multiple labs, and we're finding that not everything, surprise, surprise, is measured exactly the same. So we're going through figuring out what makes the most sense, things like time to first byte, those kind of things. We're negotiating on how to properly measure it. One thing we want to make sure as part of this is that no matter where you go, what lab you go to or what tool you use, you're going to get the same answer. So that's a big part of the effort that we have right now with this beta testing. We're also comparing measurements from different firewalls to see, what affects them and what doesn't affect them, and I'll talk about more of that in a second. Some of the output of those. That's all ongoing right now. I think we're going to wrap up probably in the before the end of the year. I think we'll have our first set of results to be companies to publish, is where we're at timeline-wise. So I know in the charter we have this date that we've missed. I think we're probably going to finish the actual testing and be able to finalize the draft probably by the next IETF. We'll have, we should have everything in a better spot to go to the working group last call. Yeah.
Why are you calling generally? So when you go into UNH or EANTC, it's paid, and yet you called it beta testing. So I'm wondering, is there? I'm not trying to split hairs. I'm just wondering, is there something you think you're missing, which is why you're calling it beta?
We're calling it beta because we're going through multiple runs. So we do a run and then we
adjust.
We exchange emails, discuss. Then you're going to see 2 of the things that we've did a first round on firewalls and said, oh.
Thank you.
Yeah, that's really why we're calling it beta. Updated firewall configuration. So this is 2 of them. The original draft, and now it says must, had a should for configuring ACLs. And basically what we found is that, obviously that affected performance. And realistically, most firewalls out will have some amount of ACLs. So we said, hey, every firewall should do this so they all can be measured correctly and have the right ACLs. So we're adding that. That was one of the things, one of the labs, the firewall vendor didn't have them configured originally, and the other lab that did. We've worked that out. Another one that came up was traffic logging. The original draft said all traffic. which obviously is going to have a big impact on firewall performance. We've updated it to say, flows, so it doesn't have to be every packet that goes through the firewall. This was really, the performance was going to drastically change if every packet had to be logged for the actual testing. One thing to note, when we do this testing, we try to set up the configuration once at the beginning to see the security of the box, and then we use that same configuration for every one of the test cases. So this is the kind of stuff we were working out through the beta. The other updates we made to the draft, there are two main things that we made. I'm going to talk about the second bullet first because it's just easier to talk about. We had a lot of extra KPIs that weren't necessary, and as we went through the beta testing, we said this is of zero value. So we removed a lot of those. A lot of the original ideas as we actually run the testing, we find that there wasn't a whole lot of value, so we're removing the extraneous KPIs. If you do a diff, you can see which ones came out. I gave an example of a couple of test cases where it just made more sense. The other thing we removed that we weren't currently measuring was application transaction latency. I wasn't sure this was the best KPI to measure things, so we took it out. And when we took it out, we had several places where we wanted to measure it. We found better ways to measure different values, so we basically took it out and found better ways to measure the different measurements that we have, and we're using those going forward. We think now we've got it better, and like I said, we're hoping to wrap the testing up for the first set of firewalls, and then it'll be more turn the crank going forward. Yeah, I think that's everything. Any questions?
Yes.
Okay.
Yeah, it's on. Okay. Tim, I'm wondering how we're best going to transfer some of the discussion here to the Bmwg list.
I've been wondering that as well. I think there's a couple of options.
Yeah, okay. Give me your ideas.
Yeah. Well, one of them is definitely to do, we have a change log. We've made some decisions. I think some of that should go directly to the list, to the benchmarking list as we go forward, as we've decided. Some of these things are happening between the benchmarking group. We should be clear when we make changes to the draft what's going on. I think now we're at the point where we should be doing that. So that's something I'm going to bring up with the benchmarking working group. I'm going to try to make an effort to match the two going forward. So I think that's going to be one of my goals going forward, so we can help give the group more insight into that's kind of a black box situation at the moment, which.
Right, and it's a chance to get additional
input
on these.
Yeah, I agree
on these items. I appreciate there may be a need to anonymize the specific pieces of equipment involved.
Yeah,
and that's fine to do that. We don't really care who's what broke this.
Yeah,
and so forth. It's really just about how do we clarify things so that measurement's clear and it ends up sort of ensuring the kind of multi-device equivalent measurements that I was just talking about. That would be great.
Yep. And then another thing we did is we did start putting the draft in Git to help us track changes. We can definitely make that link available so that people can see as commits go in and pull requests. People can easily see what changes are made. I will say that doesn't give it context, but I think that'll help. I think the other thing we need to do a better job is when we decide as a group, they get together once a week. And as a group, if we decide to change something based on the testing, that we give that feedback at this point. I think the draft's far enough along that we should be giving blow by blow at this point.
Even before you decide, it should be a
probably.
We've got an A and a B possibility here, and what does the working group think? I think that's the level of them.
Okay.
There was a time when you guys were just developing.
Yeah, we were definitely thrashing a lot more. I think it's with the beta testing. I think we're at the point where you're probably right. I will make an effort. I will bring that back to the group and say, look, I think we're at the point now where when we're trying to decide these things, we should just go to the whole benchmarking group instead of to the NetSec Open group.
Right.
I think that's fair.
That's really got to happen. Otherwise, I can hear people say, this wasn't developed in the IETF, so why should we take it through our standardization process?
Yeah,
even at informational level. So let's do that.
Okay, I will bring that feedback back to the group.
Thank you. So, any questions about this topic or the topic of measuring firewalls in general?
Karsten.
Hey, hello. Good morning, good afternoon, everybody. Yeah, thanks for the presentation, Tim. I think I wouldn't expect too many changes anymore, hopefully. So, yeah, I completely agree. We should have done a better job, and we will try to do a better job in keeping the Bmwg mailing list informed. But I think, from my point of view, I would rather like to try and progress the draft towards like last call or something like that. Not sure what your advice is on that, Al and Sarah.
Pardon? Last call, working group last call. So, yeah, I appreciate that, Karsten. Yeah, it would be, I don't think we've had the list discussion yet to warrant that. So let's get some reviews from the benchmarking community, and then we can justify that working group last call, I think. And I appreciate, Karsten, that you've given us lots of Karsten and Tim, that you've given us lots of opportunity to do that. I know that I've provided comments. I know that others have sort of held back. Let's put it that way to this point, but we need a little wider review on the Bmwg list. I think that's fair to ask. Okay.
Okay, so that's the one precondition that we need to meet, and of course to get the draft stable and to verify it in our beta pilot testing program. Or are there more preconditions?
I think the precondition for us is always to have the conversation on the list so we can get the eyeballs on it, get folks weighing in, and then as chairs we can say, yep, there's clear consensus here, or rough consensus, I suppose, but some kind of consensus to move this along to working group last call. So I realize on one hand saying that out loud, I realize you probably already know that, but it's not a, I mean, I guess that's an always precondition. There's nothing special about it. We just want to see it formally come over onto the list, have more of that discussion, and then we can easily move it along to, presumably, looking at how it's going right now, moving this to working group last call would make sense at that point.
Okay, thank you.
Thanks, Karsten.
Okay. Any other comments? I don't see anybody else at the microphone, so thank you, Tim and Karsten, both. Okay, so Al Morton is back again. This is going to be a brief presentation on the updates for the back-to-back frame benchmark. Uh-oh. It's not working. Yeah. I wonder if this one went up as PowerPoint or some stuff like that. Ah, yeah, there we go. Okay, thank you. All right. Too many buttons. Let's see. There's been lots of comments on this, including from the authors of the search algorithm drafts, Masiek, Vratko, and at the last meeting, Tim Carlin from UNH offered to provide some comments. And since the original submission deadline, we have addressed Vratko's comments, and you can see all of that going on in the email on the list. I'll briefly look at the diffs here in a moment. And the comments from Tim, also a reply on the list there. So things to keep in mind. This is one of several updates to the sections of RFC 2544. And I realize that there's actually a lot of updates that we've performed there. So the previous updates include the IPv6 address space, updates to reset and restoration. MPLS benchmarking is kind of an update to 2544. And also there's a latency measurement in 2544, which is based on one packet. State of the art of all the test equipment around is pretty much that they're measuring at least a sample of packets, and very often all the packets, and providing a minimum, an average, and a maximum. I mean, that's a de facto change to what's in 2544. So this is about measuring buffer time and trying to correct the measurement of buffer time that we get when we think we've measured it. And so we use the simple example of a traffic generator, and on ingress to the device under test, packets are stored in a buffer. There's a header processing function there, removing packets from the buffer, and then sends them at the ingress to the receiver. And so in this form of testing, ingress burst arrives at the maximum theoretical frame rate. So initially the frames are buffered, and header processing removes them, and approximately at the measured throughput rate. So when we've previously characterized the throughput, we know what this device can do in terms of that header processing rate. Frames that have not been processed or have been processed are clearly not in the buffer, and so the size of the burst that you send before you send too big a burst and packets or frames are lost is actually reduced by the header or the packet frame processing. So that's the calculation we're trying to put together here, and we do that so that we get a more accurate view of the actual buffer size and the time that's available. So a few just clarifications here in the text that we talked about with the previous testing. So the number of back-to-back frames with zero loss reported for large frame size was unexpectedly long for large frames. This is cases where the large frames and their frame header rate didn't exceed the frame header processing maximum rate. So basically there were few frames or no frames in the buffer when you were sending frames at these high frame sizes maximum that you could. And the measurement devices would not necessarily detect that. So we've actually got prerequisite testing now to say anytime you've got a test where you send frames at a particular large size and you get a throughput equal to the maximum theoretical, you don't test for buffer size there. It's just not possible. That's the way this, it's one of the ways that this update improves things. And then it's apparent that the, let's see, what's this last one here? It was found that the actual buffer time in the DUT could be estimated using the results from the throughput tests conducted according to section 26.1 of RFC 2544. It's apparent that the DUT's frame processing rate tends to increase the implied estimate. That's what I've just been talking about. According to section 26.4, and a calculation using the throughput measurement can reveal a corrected estimate. So this is the additional text we've added, and this is what that sort of what that equation looks like, although this is a new equation. So in the reporting, what we have is that we have a table where we ask over repeated tests of the longest burst length of back-to-back frames. We ask that the minimum and maximum and the standard deviation be reported in addition to the average length. And so we have a table that makes that possible. And then Vratko asked, hey, look, you're sending these frames at this maximum theoretical rate, the back-to-back rate on the ingress interface. What if I'm a tester and I know that I want to understand the frame time of a lesser rate? And we talked about that a little bit. This is the calculation that lets you figure that out. So it would be the actual buffer time for a lesser than the back-to-back frame size rate, and that's the calculation there. And you can report this value as it says now in section 6, but properly labeled so that it doesn't confuse the situation. And yeah, and so this is basically what I talked about here. There's two factors in creating this corrected buffer time. The original implied buffer time, where some of the frames have been removed from the buffer, we figure out how many have been removed by taking the measured throughput over the maximum theoretical frame rate, and that's the factor we reduce this implied buffer time by. So I think that's it. Any questions or comments on the comments and questions that were raised? Seems not. So I'm not asking to advance this at this meeting or anything like that, but Sarah?
So if you go back to the previous slide, Al, in 2544, I know this is so nitpicky. In 2544, there's one instance of standard deviation. I had to go back and look to see if it actually calls it out, and they do, and it says should be reported. And I think, or excuse me, it says should be reported, yes. And I think your text calls for, go back to one more. It's right there, I see.
It should, yeah.
Oh, yours is should as well and not may? Hold. Sorry. 2544 is may and yours is should. It's not a huge nitpick. I don't think I particularly care one way or the other. I just wanted to call out, hey, there is a slight difference there.
Well, there's a lot of differences here. So let's
You're comfortable with should?
Yeah. Yeah.
Okay.
Yeah.
Thank you.
The question is the group comfortable with should? So I see one nod, so that's good. And I think it's good to characterize the variability as well. I mean, I think that's very often the difference between may and should has been determined, in this particular case, 20 years ago, by the ability to look over the individual results. And I think that it's not a bad idea to make this a recommended. It's still not must. So,
yeah, I think the test gear equipment manufacturers are going to settle the score on may or should here anyhow.
Right,
and
that's
we'll
right.
see. So I just thought I'd ask.
Yeah, no, that's good. I'm glad you made that check. There's only a couple of, the 26.4 section description of this test is extremely concise. We've now got like about a 6-page memo that goes into this. So and it's and it's doing a lot more than 26.4 ever envisioned. I think I can't wait to get Scott Bradner's review.
So yeah, I was going to ask you that offline. Actually, I wonder what's Scott going to think about this.
I don't know. We'll find out. I guess I'll have to. Let's make sure he gets the Opster review. I think he'll be glad to see this. So, any other comments? No? Okay, good. Thank you. So that gets us through all of the working group drafts, and now I guess we're going to have the remote presentation from Manuel.
Okay, again, test 1, 2. Does the mic work?
Yes, we can hear you.
Okay, great. Hello, everybody. My name is Manuel Poister. I'm going to replace Rafael Rosa because he was not able to make it. And I'm trying to present our updates for our draft on methodology for VNF benchmarking automation, which is now submitted in version 5. If you go to the next slide. This is basically what happened so far. Just to briefly put you into picture, this draft is about automating benchmarking of virtualized network functions. So it's not about what measurements to actually perform on these virtualized network functions. It's more about how to specify the benchmarking experiments and how to specify the results, and how to automate everything end to end, because the general idea is if we have our network functions entirely developed as software, we can make much more use of automation and run those experiments fully automated. On the next slide, we have an overview why or what was updated in the draft. First of all, we are presenting in that draft different models which describe, on the one hand, how the experiments should be performed. Those models are called VNF benchmarking descriptors, or short VNF-BDs. Those descriptors can then be read or used by automation tools to actually run those benchmarks. For that, we updated the VNF-BD specification, and we also provide now young models which specify how such a descriptor has to look like. And we started to also present a model for a VNF performance profile, which is in our case the term for describing the results from such an automated benchmark, and also started to develop a young model for this. Further, we addressed comments which were sent to the mailing list by Luis Contreras, and I think there were even more comments coming up on the mailing list. I remember comments from Steven van Rossen. They are not yet addressed, but there is an upcoming number of reviews on the mailing list which we are working on. If you go to the next slide, these are the main points in our update this time. First of all, as I said, this VNF-PP, so this is basically a model which gives you the result from such an automated benchmarking procedure. It's basically kind of a template in which these automation tools can fill in the measurement results. So in general, the measurements are divided into tests, subdivided into trails, and so on. And this model basically describes how you can give those results in a structured manner so they become machine readable. So you can define different metrics, you can define how many trails are executed, things like this, and all this is basically captured by this model. So you have a kind of a machine readable outcome of your benchmarking. Then the next point are these young models, as I said. Those models are right now available on GitHub. We put the link here, so you can go there and check out those young models. This is also something we have as a question. We are not yet sure how to add those or attach those young models to an IETF draft. So we know that the IETF has their young modeling rules, and we try to follow them. And we know that in the data tracker, there are existing drafts which have young models assigned. So our question would be how to do that, how to get our young model attached to this. So maybe we can get an answer to this later. And in addition to the draft, we also updated our two reference implementations. One of them is GIM and the other one is TNG Bench. This was also one issue which came up, I think, on IETF 104, that the GIM open source tool was not yet available open source. This has changed now, so both tools are available and linked from the draft. And on top of that, we did first test runs with both of the tools, or the results from this test runs are also available on GitHub, and you can check them out. The idea here is that we try to compare if we give both of our tools such a benchmarking description, let them run the experiments, how similar are the results obtained by them, and do they really do the same when given the same information? And the next slide just gives a brief example on this. Basically, on the left side, there is a picture of the model, and on the right side, there are the example outputs of the two tools. So they are not 100% aligned, but they are pretty close to each other right now. We are looking into the details here. This is just to give you some examples. I think we can directly go to the next slide here. And yeah, that's basically on our to-do list. The VNF-BD, as I said, were checked with our reference implementations. The same check needs to be done now also for the VNF-PP. This is work to be done. We are still trying to update those models a bit because we got some additional feedback from our colleagues. So there might be minor changes. And I think there are a lot of synergies to other drafts in this working group, especially the young data model for network interconnection tester management. So I'm quite interested in in their presentation. Maybe we have there some similarities or can make our models compatible to each other or something like this. So this is something where we think a collaboration might be possible. And yeah, going to the last slide. To recap, 0.5 was uploaded. Comments are arriving on the mailing list. We try to capture all of them and address all of them. The reference tools are now finally available. And from our stage, yeah, we think the draft becomes more and more stable. And once we are able to add the young models to these IETF drafts in the data tracker, we would be interested in what the next step could be, if we should aim for having a last call or something like that. That's more like an open question here. And that's basically everything. Thank you.
Okay, thank you. Thank you, Manuel. Stay with us for a moment there.
Sure.
Folks who would like to make comments, please go to the mic now.
Hi. Vladimir, Whiteside Instruments. It is really relevant, your draft, to the need to have a formal way to represent test results. And the idea is good, but I think you need some help with the young models. I have looked into them, and they really need some review and refactoring. So I can join the discussion, and I think it's going to be a lot of changes. But if you are dedicated to working with this draft, I can help you. This one thing. Second thing, this is very easy to add the young code to the drafts. You should just look to another draft that has young and just add it. I don't know if you're using XML or directly write it as text, probably XML. So just check some of the sources. It is a 5-minute effort, and you can have your young models added.
Okay.
It's not something to discuss. And one more thing, young, you should write it with capital letters because it gives bad impression.
True, I also know this
Yes.
during the presentation. Yeah.
But I don't have focus on what you have as a topic on your draft, but it should be done well, and you should put really effort into making it properly, because all the tests are going to be integrated into that. So it really needs an effort.
Okay.
Otherwise,
Yeah, thank you very much. We would be very, very happy to see some feedback to the models as such, because for them, we never yet received any feedback. So this would be really, really appreciated.
So, Vlad is being very modest. One of the drafts where you can look to see how a Yang model is incorporated in an internet draft is his draft on a Yang model for control of traffic generators.
Okay.
So that's a good place to start, and it's right within our working group as a good example.
Okay, thank you very much for the pointer. I noted, and we will have a look.
And then, Manuel, just to close the loop on the comment you made on the previous slide with the testing results.
Mm-hmm.
Here, I'd be very interested to see when you guys dig into what the differences were here, what you come back with.
What we noticed, or those experiments are testing a IDS system, which is deployed as a Docker container, and we run traffic traces through the system. And the difference is, on the one side, of course, the absolute numbers, because experiments might be performed on slightly different hardware. We were more interested at first into seeing if the trends are the same, and this is something we could confirm here. Don't be confused, because the colors are exactly swapped. So the blue in the one plot is an orange in the other plot. That's a problem of the plotting library, I guess. But the general trends seem to be the same, and this is what motivated us to continue this work. I think if you run, or the goal is that if you run the experiments on the exact same machine, because it always depends on your virtualization infrastructure, that we then try to achieve, or want to achieve, the exact same result. And I think from our methodology, this should be possible, but this needs to be confirmed with additional experiments.
Yeah, exactly. So I think one of the things that we've struggled with in Bmwg with virtualization is how do we confirm the ability to run the same test over and over and over. And I know Al and I sometimes differ a little on this, but on one hand, you're usually looking to get, if the exact same variables are run 10 times, one would expect the same result. Sometimes we don't. And I think there's a lot of angst around virtualization where how do you confirm that, hey, I can run that same test 10 times so that I have 10 apples to apples comparisons and 10 numbers that I can actually point to say, yep, this makes sense. And so because you've done a lot of heavy lifting here and you said you were digging into it, and I thought, okay, if you guys could continue as you update the draft and Vlad is helping you, when you guys come back next time in Vancouver possibly and you present again, hey, just, I'd like to keep focus on that because it's our heritage. And you're also helping us prove out and solve to say, yep, we can actually benchmark. And here's how we went about it. And here's what we're seeing as you're doing it, which is exactly what you've got here. I just want to make sure you continue to do so.
Yeah, exactly. Yeah, that's basically on our agenda. That's one of the main areas of focus right now.
Thank you.
So I've got a question about these graphs as well, Manuel. You said this is for an intrusion detection system?
Yeah, it's Suricata. I think it was version 3, if I'm right. I think these example drafts showing the number of drop packets, and they are measured for different traces with different flow sizes and so on. So in the experiment folders of the GitHub repository, there we have specified the or the information is available which exact setup was used. I couldn't put everything on the slide.
Okay. All right. Well, then we'll have to take a look at that and appreciate this results presentation a bit more.
Okay.
Good. Let's see. Oh yeah. And have you tested more than one type of VNF?
Yes. We haven't compared with both tools, but at least for TNG Bench, where I'm mostly working on, we tested not only the Suricata and intrusion detection system stuff. There we tested a couple, so Snort, Suricata, and so on. We also tested things like HTTP proxies, load balancers, and recently we also tried to do first experiments with some IoT-like virtualized network functions, more specifically different kinds of MQTT brokers, and to see if we basically can use our approach of describing experiments with very different kinds of network functions. And that worked well, even though it always needs to be some custom tailoring of the experiments, of course. And this is basically what gives us the input, what might be needed in addition in our models. So it's kind of our own cross-check, eat our own dog food at this point. So
Manuel, there's enough variability across that list of VNFs that I feel like you must be in some sense defining your own VNF specific benchmarks to measure as you do that. So that's an important part of our work as well, and it's usually something that we have a complete sometimes a set of internet drafts in order to agree upon. So for a load balancer, for example, I don't think we've done any benchmarking work on load balancers. It would be interesting to get your ideas on what the proper metrics are and what we can take for that, which might be useful to the rest of the industry.
Okay, yeah, we can certainly work on this and polish those work and try to provide more insights here. Yeah.
Yeah, and if in Vancouver, we're always good testing junkie nerds in this working group. If you wanted to share some of the output or graphs that you had generated from those are always hugely popular in Bmwg. We would thank you for it. And I realize you're going to refine this draft, but to Al's point, you've tested a bunch of different types of VNFs, and having what you were looking at and how you did that as future potential drafts would be hugely beneficial to us testing on our own in our day jobs, right? So I would encourage you to consider more than just load balancing. Share any ideas that you have.
Okay. Okay. Yeah. Sure.
Thank you.
Thank you very much.
So, you're looking for working group adoption, and in order to get there, we have to have at least some people in the working group who have looked at the draft. And I think you mentioned. Let me look back here. I think you guys did get some comments from Luis. Help me out. Did anybody else provide comments on the list?
I know there was Stephen Van Rossum, a guy from Ghent, sending an email. I haven't looked into the details yet, and it still needs to be addressed. Those are the two which I'm aware of so far.
And I think I provided some comments on a very early version of this, but not since.
So yeah.
So I think before we examine a working group adoption, let's get a few more reviews and.
Sure.
Yeah. So we have at least two volunteers, Sarah and Vladimir, who will do a review in the interim, and that will help our case to adopt this.
Okay, great. That would be great to hear from you.
Anything else from the group assembled here? Seems not. Okay. Well. One thing I always want to encourage people about is one way that folks who are proposing new work can help each other is to read each other's drafts and perform reviews. And even if it's work you're not familiar with, you may learn something, and that's good. Always a good thing. So consider that as you come to the microphone today and then stand here boldly asking for the working group to adopt your draft. You can get some help by helping others. So next up is the containerized infrastructure draft. And there we go. Here's your controller. And Wangbong Lee will do the presentation. And please go ahead, sir.
Yep. Thank you. I'm Wangbong Lee from HV. The draft, the title is Consideration for Benchmarking Network Performance in Containerized Infrastructure. I'm presenting briefly some minor updates for the huge page up and NUMA. These are part of our interest in this draft. So we are in this draft. We are trying to how to configure those things and what impacts on those things to containerized networks. So we are still trying to find out, and then in this hackathon, so we are still try out those things to how to configure and what performance issues on them. This directory is we add some more explanation about huge pages and NUMA. Huge pages probably the container is isolated in the application level, and administrator can set which pages more granular level, but like Kubernetes allows to use a 512 megabytes, and but we are still trying to for that value, and then we next resource things as NUMA is we are still trying to find out what's going on. From this hackathon, we are still trying to verifying the CPU allocation using current container engines, where two techniques used, Kubernetes CPU scheduler and CMK, and then we are measuring throughputs with two things with CPU variations. And next is we're still trying to verify the huge page values, but and our results and our test environment, the slides, it's from the web page, so you can find out that. And this is our basic test bed, and so we can use the traffic generator for the tracks and some container networking technology, TPK, and then we use the CMK and Kubernetes natives, and the part, one of the part is for application we use the Suricata, and then we are more simple one, we use the just forwarding application. And part of this testing, we some problems on some point, you know, the between 2 points in VPP interface and pod interfaces, we have some packet drops, which is error checks. So most packets are dropped on that point. So we still, you know, very and some we are regenerating some traffics and reinstalling some components, and then after there's no any results. So we are you know the change the interfaces, which is the Mellanox 100 gigs, but we changed the 1 gig Intel interfaces. It works. So we're gonna that is the we find out in this hackathon, and then you know some next step is you know with a new interface or with new interfaces and new testbed, we are still keep trying to find out more. And it's our some learning from the hackathon, and we are just still keep trying to update new technologies, and then we still more find out what's going on the Mellanox interface. That's the problem on that interfaces, but I'm not quite sure. But we're going to find out. So next step. One of the next step is from your comments, and then updates the draft. And then next, the BMW hackathon, we will still trying to our experimental things. So finally, you know, in our draft 2, we are still trying to provide how to set the NUMA and memory things, and then we are going to propose some test beds. Yeah, that's it. Thank you.
Thank you, Wengbang. Any questions or comments about this this benchmarking? I mean, this is containerization is going to be the kind of the future of virtualized deployments. We've got pretty good understanding of the hypervisor-based virtualization. We have a lot to learn about containers. There's obvious advantages and obviously a lot more things to learn about how making that work in general. I think some people are very good at it, but they don't talk about performance, except in loading the images. Everybody knows that's going to be quicker. So one additional point I wanted to make is that your considerations draft. And I think I mentioned this to you to you all at the Hackfest. The considerations draft could include some information on troubleshooting test setups. I think you guys are generally going to get some a good experience doing that, and some of the tricks and tools in getting a setup working, things that you could recommend. These are also considerations with a new technology that I think everybody is going to appreciate. So feel free to add your experiences there. I'll go ahead, sir.
I would extend that to say it would be nice to see the outcome from the hackathon. And on one hand, it's always frustrating, I think, when you go into the hackathon and things don't work perfectly, but you're also experiencing, I think, a lot of what we are experiencing in the field right now outside of IETF, just in our day jobs. And so capturing, presenting what you're seeing in hackathon in Bmwg would be helpful. And then extending that to, hey, as you're learning things and troubleshooting through the hackathon, adding that too in terms of your troubleshooting or things learned or best practices, and then thoroughly documenting the test beds. I know you're going to present future test beds, but formally documenting what was used is helpful, because I think, again, we're seeing huge differences. I've seen huge differences depending on the NIC that I use. And it's interesting you're saying the exact same thing. And I don't think this is unique to us, but again, it helps when we set up a test bed to understand, if I really need it to work, at least I can point back to this draft and know, here's what they used, and here's what I saw. And so it gives me some hope or a good, sane starting place to go. Does that make sense?
Yeah.
Okay. Thank you.
Thank you. Yeah. We are sharing our results always from this website, and we will welcome to your comments. Thank you.
Thanks. I'll just mention too. That's okay. You can. Oh yes, that we need. I'll mention too that among our slides, I put the hackathon slides, and it's sort of the next deck in the list behind this one. And you can see there some of the additional experiences that this author team was kind enough to share in their 3-minute presentation. We all get 3 minutes, but it was an excellent opportunity to spend some more time together with Vladimir and also with the whole containerized infrastructure team. We sat together in a couple of tables side by side, and were able to give little presentations about what we're doing, and then subsequently the results of our tests. I highly encourage that. So folks who have the ability to use the hackathon as a kind of a measurement experience exchange, it's a great idea. I can tell you last year at here in Singapore, 2 years ago in Singapore, I guess it was, I was struggling with a particular configuration. I couldn't get it going, and I got a lot of help, but I had to leave without getting it going. So in the next couple of weeks, though, I did get some help, and so that was the kind of thing that made a difference. So in any case, it helps to have more eyes on what you're trying to accomplish. This is a great place to do it. Thanks. Right. So, like I said, these are the hackathon slides, but we won't show those today. Now we've got Vlad on, who was also at the hackathon, I just mentioned, and yeah, there we go, and going to talk to us about the network interconnect tester. Here you go. The one on the right goes forward. And this is your most recent version of slides, right? I got those.
Yeah, those are exactly as I want them. Text only, except one big
You're going
image.
to raise that mic, I think, a little bit. Yeah.
Yeah.
Or just take it out.
Take it out. Not very experienced talking to people.
I was going to move up a little bit. See this pink X? That's going to be where you are. Move the stand out of your left. There we go.
Okay. Thanks.
Sorry.
Yeah.
Rules are rules.
So I just wonder if anyone is interested in the draft by the title, or if someone has read it, or if is generally interested in Young or test generators. So a Young model for a test generator, that's what this aims at. So when you configure TRX, for example, in order to generate traffic, you do it with some interface. If it's XML or a graphical interface, this is just a way to configure a stateless traffic generator and analyzer with Young, so that it can be used in a netconf interface. In the same way as a switch or a router, when you test them, you don't want to use different interfaces. At least until now, there are different interfaces. For example, Aniritsu uses Skippy, which is meant for frequency analyzers and things like that. They use that interface very successfully. Actually, that's one of the best interfaces you can get. And that's outdated. It's not for networking. And I think Young and netconf is what has to come at some point. So this is what this draft is about.
Hold the mic up a little bit closer to you.
Yeah. Okay. Well, so this is giving a summary of the deficiencies of the current approach by all the companies that develop traffic generators and analyzers. In other words, called network interconnect testers, which is a term that comes from RFC 2544. Now, there is no standard-based management interface for those devices. So it is taken from different industries and adapted to networking. There is no multi-vendor interoperability. You can buy two different traffic generators, and they will have absolutely different interfaces. You can use a lot of time developing tests, and then you cannot move to another company because you have used the interface that is absolutely different from everything else. You don't have that choice. Three, they don't have a transactional model definition, which means this is what you can get with Young and netconf, and this can allow you to actually simulate a traffic generator in a discrete event simulation. So if you want to specify a traffic generator in a simulator, you really can't do it with something that already exists and is standardized by the IETF. So people in that industry are defining their own models to do that. And there is no standard for generating reports that document absolute any transaction that you do to those devices. So here comes netconf. It is intentionally made to be readable by humans so that all the transaction with the equipment, you can just load to a file and you can use it as a legal document. This is a big advantage. So how does IETF Young data model for network interconnect tester management solve these problems? A very important point is to have multi-vendor interoperability. Tools can be reused. You have a lot of netconf and Young tools available. You will be able to use those with any generator and analyzer. Test programs you can write that are going to be compatible. The generators are going to appear just like a replaceable bricks. So you can buy from different manufacturers and they will seamlessly be replaced. And one advantage is that you can actually have self-tests written in open source language so that you can adjust parameters and verify that your traffic generator satisfies those requirements. So if you have a Python script that does a self-test, you can change values and figure out exactly what its jitter point is for different traffic patterns. You can't do that today. You have to just trust the manufacturer you buy a traffic generator from. You just have no way of proving he doesn't do something right. And you can do it, but it's not easy. So transactional nature of netconf allows you to have a common commit which ends every time you want to actually affect the device in a way. Now this is done with the different commands, start commands, which are specific to the interfaces or to anything else. With this, you can do device changes in parallel. So you send a commit to all the devices in the network and they start applying the changes simultaneously. You can't do it today. If you have multiple generators, you have to do the specific changes which start the traffic generation, and you can't just automate it by sending commit to everything after you have prepared the candidate database. And that's the reason it's not scalable. It's not easy to document, and it doesn't have any support in discrete simulators. So you don't have a model of an Anritsu tester in OnNet++ that you can just put with the configuration you will use on a real device. All this can change with a standard model. Yeah, that's the standard session that you can just capture, and you have a ready document for the test you have performed. So in the hackathon, we wanted to demonstrate this concept works. So we took RFC 2544 setup, and we picked some real devices that generate and analyze traffic in hardware. So taken with this diagram, which is one of the diagrams there, we wanted to have a Python script that takes the input in XML and produces a result in XML. Now, we didn't accomplish that part because this is what the previous draft was about, where you have standard common input for the tests and a common place to store the results. What we did was create a physical setup. This is the running hardware that's needed. And we managed to make a simple trail that complies with the 2544 RFC. So when they discussed trails in the previous draft that are going to be registered in that result XML, they have to be described somehow, and that's what we do with that traffic generator model. We describe a trail which generates the traffic. So we have that in GitHub. These are the results. And I think it's interesting for anyone who is wondering how this YANG is going to be used to write a simple Python script to configure things compared to what's available today. That's the two Python scripts that are they're using a YANG CLI, which makes YANG in netconf much simpler. You don't need to deal with XML on the command level. You just do it on the replies that you get. So I really recommend that for people doing testing and are used to command line and Skippy and interfaces like that. And then you have the reports generated, which I mentioned with netconf. So, and you have a configuration which actually is based on the topology level, specifying how all these devices are connected, so that the test has the credentials to connect to each of the devices, has the models, and can actually figure out things without you specifying everything on the command line. This is how the test is run. So when you want to run one trail, sending packets from the one port going on the other on that switch that we used, you use a set net command which initializes everything on that net with a fixed predefined setup in XML. And then you start the test, which executes, in this case, it executes a 64-byte with a very big interframe gap, if you notice here. And I'll explain why we have to do that. So the switch that we used for tests was working very well on hardware mode when it was no filters defined. And there were no packets dropped, actually. You have to run very, very long sequence to get the packet loss. But when we configure it in a special mode, which makes it act as an open flow switch, it does it in software. And it is listed by the manufacturer. It's just experimental. And it works, but it drops most of the packets, as you can see. You have to have less than 1% of the traffic so that it doesn't drop packets. And that's it's simply unusable, but it is possible to enable it. And that's, for my case, it was perfect. So we had a run with losses with 9,000. This is 9 times 1K. And this is how the result looks when it is dropping so many packets. You have 60 seconds of run. You generate a lot of packets. There is a lot of packets being dropped. And this is on the border. Before that, it's even worse. So when we get to 9K of interframe gap between each packet of 64 bytes, then it starts working much better. And in the next test, with 10K, it starts working without the loss. So this is something that the bandwidth test would do automatically. We did it manually because we didn't make the search algorithm. But the positive thing is that we made a simple script that does that. And then this can be reproduced and called automatically. But this we have to do in a next pass. So this is how it looks when it is not dropping any packets. It gets about 1.2 milliseconds of latency. And yeah, you can compare it with this. Then it's yeah. So the results are not particularly practical. This is not something you would get on a regular switch. But we used netconf interface with young models on all the 3 devices. And the switch was configured as a flow-capable device, having a wrapper around the open flow, presenting it as a netconf and young device. So it was a pure young system based on generators and a bridge, which I have been looking forward to accomplish for some time. And I'm very happy that we made it, even though, yeah, so that's about it. That's the references. If anyone is interested in that topic, I really recommend, if you're doing anything with Young and netconf and you're configuring devices, in order to test them, to look into the Python scripts, because you don't want a controller in your way when you're testing a device. You want to have a direct access so that you test the device and not the controller. And I haven't seen any good automation scripts around there. So this is good experience, and I recommend it to everyone who's interested. Yeah, so that's about it.
It's really good. The every statement you made about sort of the universality of the Yang model, anybody who's been around IETF for a while should resonate with that. And don't run away. Maybe there's going to be some questions or comments here for you. I think, well, you and I exchanged some mail on the mailing list, and I think you've covered those points. I was basically asking or kind of verifying where this fits in the sort of in the hierarchy of the complete turnkey test device. And what was clarified, I think, as Vladimir said, was the Yang model basically commands the test equipment into one configuration, but very often we want to run multiple trials at that configuration. So you'd basically repeat the test, and then if you wanted to use a search algorithm, you would change those parameters and run it. So as you said, you were running it manually. That's completely possible to do, but a lot of people want to do this sort of in an automated way, and that's logic that would operate and use this Yang model to accomplish it, right?
Yeah, actually, I think the search algorithm is not difficult to develop when this infrastructure is working. The tireless days and nights to get this working go into actually dealing with issues with the young parser, the netconf interface. And now that it's ready, I haven't spent a single minute thinking about the search algorithm logic, but I think there are a lot of people that can implement this without investing time into the issues that I have been dealing with. And there are probably specialists who have already done this. So they can just take this function that returns them results, and they can provide the parameters, and they can just play with that. If someone is interested, I'm very interested to work with him.
Very good. Very good.
Yeah.
Because we've got actually several candidate search algorithms being discussed here. Those guys are the Masiek and Vretko are the experts in their algorithms, and I guess they're using the T-Rex tool, so they've already got those going. But it would be good for them to kind of look at this and see how they can help. Also, I mean, we have one. And let me just go back here for a moment, because I saw in the picture Vladimir's excellent and transportable test setup is what's dominating the picture here. But behind it is my laptop and my little black bare metal tester that I was using in the IP capacity testing. So I had a much more efficient, fits in my backpack kind of setup for my testing. But there's a search algorithm we're using there as well, so that may be something we can look into. Because I think, there's clear crossover between what we've learned in the benchmarking world and implemented in the binary search with loss verification when we went to do the production network search algorithm that we use in this IP capacity testing for the access links. So there's a good. I think you've done an excellent job and left a good break point for others to jump in with their expertise. That's a good point, Vladimir. Go ahead. Yeah. Okay, go.
Yeah, hello. Thanks for the presentation. Really cool. So what I don't understand yet is, what is the relationship of this draft going to be to existing test methodology RFCs? So typically I know from other IETF working groups that the Yang model RFCs are linked to protocol RFCs. So I wasn't sure whether what was your point here, if you are trying to create an RFC for a Yang model covering RFC 2544 or any related stuff, or just everything. That's question one. And question two is, the main problem from my point of view is not only configuration, it's also reporting formats. Do you have any thoughts on those?
What was the last part of the question?
Last part of the question was one of the main problems is not only provisioning a test tool, like understanding how to configure it, but also how to get the results.
Okay. I understand the question. The goal is very specific. It is alternative to the currently existing interfaces to the interconnect testers. So it allows you to measure things with interconnect tester. It doesn't focus on how those results are going to be reported. It doesn't even focus on RFC 2544. The good thing is that 2544 is a very simple, elegant algorithm using only stateless traffic. And it is perfect match for what this interface accomplishes. So you can implement the 2544 algorithm using that interface. The Yang modules, they are extendable. So they are going to be extended by different features, different complexity, but they are presenting a stable base for that. So this is doing like the base for adding stateful generation, more complicated analysis, and custom protocols and algorithms. So this is as simple as being able to specify a repeated sequential pattern with like precision and determinism that is needed for this kind of technologies that require it. So in my case, we are using an FPGA hardware to do that because that's why you need it. You could use T-Rex if you didn't really care about the determinism. You can just generate a lot of packets. But if you really want to generate RFC 2544 traffic, which is equally spaced with interframe gap, which is repeatable and doesn't jitter, then really you need the hardware generator. That's why people are buying those devices. With this model, you are specifying actually a configuration that goes into the hardware. You can implement it in software as well, of course, but it is mainly targeting deterministic hardware generation. So you are specifying a table of streams, how they're going to be separated, if they're going to be a burst, what kind of packet is going to be generated. And the analyzer side, because there are two modules, the analyzer side specializes in measuring latency, sequence drops, and other things. For the normal counters, we are using IETF interfaces. So input packets, output packets, the test is using the standard counters. So in a way, this module, it's forcing also implementation of the standard IETF modules. So if Anritsu, for example, Spirant, Xenon Networks tomorrow decide to use IETF modules to control their equipment, this will be very positive for anyone who is used to those modules. Then you don't have to be familiar with their own interface to retrieving a counter. Then you can just use IETF interfaces in addition with the traffic generation modules, which do that. So I think it's a very simple concept. I'm not focusing on this being an RFC or standard track, just getting the visibility and working on it. I think I'm very happy with that. So it's, I don't know if I made myself clear.
So partly. So I'm not sure. With my question with regards to the results wasn't really answered, or maybe I didn't understand it. So you said IETF models or modules. I'm not sure if I understood. Those can be used for results interpretation or results transfer. So maybe we can take this offline.
So gentlemen, hang on. So I'm sorry, we are 5 minutes over time. So if we could please, Karsten and Vlad, could you take this to the list? Awesome. I'm so sorry. Thank you. All right, folks, thanks for hanging out the extra 5 or 6 minutes. We appreciate you. We will see you. I thought we were done at 3.
No.
We're done at 3. Am I reading the drop? Oh. Yeah. Am I nuts? 3. Yes.
That's weird.
Look, it was your sessions. I thought maybe you were giving up the time, so I apologize.
I just didn't know that we were running over. I thought we had 2 hours.
Oh, I'm sorry. All right, so thank you all for hanging out late with us. Please take the comments to the list. Read the drafts as you've seen. When you read somebody else's draft, they're more likely to help out on yours. And then hopefully we will see you all in Vancouver. Awesome.
And please, guys in the back who came in late, sign the blue sheets. Roland and your friend, please do. One other point, which we forgot to mention, is that we've declared publication requested on the EVPN. We did mention that. I didn't remember it. At least I don't see it in the notes here either. Oh, you did? Okay. It
down under the come down to the next section where it calls for the EVPN draft.
Okay. I still don't see it. I thought it was. I thought it would have to go in here where we got.
Yeah, see the note there.
Oh, sent through. Okay, got it. Good. Okay, it's covered. Good enough. All right, folks. Until next time, please read the drafts. Thank you. Sorry, Luis.